Alright, welcome back everyone. Today's video covers the triangle quiz review. Starting with number 1, it says solve for x. That's for 1, 2, and 3. Right? X is the short leg of this 30, 60, 90 triangle. Here's a picture of the ratios of a 30, 60, 90 triangle. So 24 is twice A, or twice the short side. So that means the short side would be half of the hypotenuse. And half of 24 is 12. So x is 12. For number 2, we want to find x, and x is the hypotenuse of this 45-45 triangle. Here's a picture of the ratios of a 45-45 triangle. The two legs are the same, a, and the hypotenuse is a times the square root of 2. So in this triangle, 12 is a, so the hypotenuse would be a square root of 2, or 12 square root of 2. So that's what x is equal to, 12 square root of 2. And here is number 3. We're trying to find the length of this vertical side x. Well, we have a 30, 60, 90 triangle where the angle here in the upper left corner is 30 degrees. The side down here at the bottom would be considered A. That's the short leg of a 30, 60, 90 triangle. 3.8 is 2 times A. So that means A would be half of 3.8, which makes 1.9. And so if A is 1.9, then we can figure out the longer side, because that is simply A multiplied by the square root of 3, as we see here. So 1.9 is A. That means this side here is 1.9 times the square root of 3 for this vertical side. So the answer is 1.9 square root of 3. All right, for 4 through 11, we're using the diagram on the right. And for number 4, we're finding the length of AB. Now, AB is the hypotenuse of this triangle, and we can use the Pythagorean theorem to find the length of the hypotenuse. So we'll call the missing side the hypotenuse. We'll call that C. A is 8 and B is 15. The Pythagorean theorem says A squared plus B squared equals C squared, or 8 squared plus 15 squared equals C squared. Now, squaring the 8 and the 15, we get 64 plus 225, and adding those together, we get 289, which is C squared. So C is the square root of 289, which is 17. So our hypotenuse is 17. And thus, number 4, AB is 17. Question 5, we want to find the sine of A. Now we know A is the angle up here, and we know sine is opposite over hypotenuse. The opposite of A is 15, and the hypotenuse is 17. And therefore, the sine of A is 15 over 17. That's opposite over hypotenuse. The cosine of A is the adjacent over hypotenuse. The adjacent of angle A is 8, and the hypotenuse is 17. So that would be 8 over 17 for the cosine of A. The tangent of A is opposite over adjacent. The opposite of A is 15, and the adjacent is 8. So the tangent would be 15 over 8. The sine of B, sine is opposite over hypotenuse. Now the sine of B, the opposite of B, would be 8, and the hypotenuse is 17. And therefore the sine of B would be 8 over 17. The tangent of B is opposite over adjacent. The opposite of B is 8, and the adjacent is 15. So the tangent of B would be 8 over 15. Now for number 10, we have to find the measure of angle B. Now to find the measure of angle B, we're going to use the sides. 8 is the opposite side, and 15 is the adjacent side. So that means we're going to be using tangent. Now to find the angle, we have to use the inverse function, the inverse tangent, or also called arctangent. So we will say that angle B is equal to the inverse tangent or arctangent of opposite over adjacent, 8 over 15. And then we just plug that into the calculator. And my calculator tells me that the inverse tangent of 8 over 15 is 28.072, so that is the measure of angle B. All right, number 11, we want to find the measure of angle A. We'll use the sides 15 and 8. 15 is the opposite of angle A, and 8 is the adjacent. So we're going to use inverse tangent again. So it's going to be the inverse tangent of opposite over adjacent. So that's the inverse tangent of 8 over 15, and we put that in our calculator. And in the calculator, the inverse tangent of 15 divided by 8 is 61.928, so that is the measure of angle A. All right, for 12, 13, and 14, we're solving for x. For number 12, x is a missing angle, and 7 is the adjacent side, 15 is the hypotenuse, and so we're going to use inverse cosine. Okay, so now we're able to write that x is equal to the inverse cosine of the adjacent over the hypotenuse. That's 7 over 15. And then we put this in the calculator. All right, the calculator gives us that x is equal to inverse cosine of 7 over 15 is 62.182 degrees. All right, solving for x here in number 13, x is the hypotenuse, and 46 is the opposite side of the angle 47. So we know that sine is opposite over hypotenuse, so we can say that the sine of 47 degrees is equal to opposite over hypotenuse, or 46 over x. After multiplying by x and then dividing by the sine, it becomes x is equal to 46 divided by the sine of 47 degrees. And then we put this in the calculator. And so we calculate x to be 46 divided by the sine of 47, which is 62.897. Right, solving for x in number 14, we notice that x is the opposite side of the angle 34, and 21 is the adjacent side. So that means we're going to use tangent. So we can say that the tangent of 34 degrees equals opposite over adjacent, which is x over 21. We'll multiply by 21 on both sides. So x is going to equal 21 times the tangent of 34. Let's put that in the calculator to get our answer. All right, we're getting x equals 21 times the tangent of 34 degrees, which is 14.165. All right, so it says solve the triangle ABC where angle C is a right angle. So that means that angle C being a right angle, we know that angle C is 90 degrees. So we say the measure of angle C is 90 degrees. I'm going to call this missing side here between C and B, I'm going to call that x, and we can use the Pythagorean theorem to find x. So we can say that x squared plus 24 squared equals 25 squared. Squaring the 24, you get 576, and squaring 25, we get 625. We'll subtract 476 from the 625 to get 49, and then we'll take the square root, and so x is 7. All right, now let's find the measure of angle A. We're going to use an inverse function. So we notice that the 24 is the adjacent for angle A, and 25 is the hypotenuse. And so adjacent over hypotenuse is cosine. So to find the measure of angle A, we need to use the inverse cosine. So we'll say the inverse cosine of adjacent over hypotenuse, which is 24 over 25, and then we put that in the calculator to get our answer. And the inverse cosine of 24 over 25 is 16.260. That's the measure of angle A. Now to find the measure of angle B, we also need to use an inverse function. Now 24 is the opposite of angle B, 25 is the hypotenuse. Opposite over hypotenuse is sine, so we need to use the inverse sine to find the measure of angle B. So the measure of angle B is going to be the inverse sine of opposite over hypotenuse, which is 24 over 25, and let's put that in the calculator. The inverse sine of 24 over 25 is 73.740, which is the measure of angle B. All All right, we have found all of the missing sides and any missing angles, so this problem is complete. For number 16, it says to solve the triangle LMN. First, I'm looking at the measure of angle L. The measure of angle L plus the measure of angle N has to add up to 90 degrees, so we can simply subtract 63 from 90 to get the measure of angle L. So 90 degrees minus 63 degrees, that results in 27 degrees, so the measure of angle L is 27 degrees. All right, let's call side MN, let's call that X, and then we'll need to solve for X. I'm noticing that if we use the 63, that X would be the adjacent side of 63, and 13 would be the opposite. And so that would call for tangent. So we can say that the tangent of 63 degrees is opposite over adjacent, which is 13 over X. And so X is going to be 13 divided by the tangent of 63 degrees. We put that in our calculator, and we get X to be 6.628. The other missing side is the hypotenuse from N to L. Let's call that Y, and then let's solve for Y. Well, if we use 63 again, then 13 is the opposite side, and Y would be the hypotenuse. So that would call for us to use sine. So we can say that the sine of 63 degrees is equal to opposite over hypotenuse, which is 13 over y. And so y is going to be 13 divided by the sine of 63 degrees. We put that in our calculator. And so y is going to be 14.590. All right, we found all the missing sides and angles, so number 16 is done. All right, number 17, it says a tree casts a 20-foot shadow when the angle of elevation of the sun is 42 degrees. Find the height of the tree to the nearest hundredth of a foot. The first thing you want to do is to draw this picture. Here's the tree, and it says the shadow of the tree is 20 feet. So the shadow would always go on the ground. And it also says the angle of elevation was 42 degrees, and the angle of elevation is always the angle from the ground. Now we'll call the height of the tree h, and this is what we're looking for. And the angle 42, in relationship to the angle 42, h would be the opposite side, and 20 would be the adjacent side, so we'll need to use tangent. So we'll say that the tangent of 42 degrees is equal to opposite over adjacent, which is h over 20, and then multiply by 20 on both sides. So h is going to be 20 times the tangent of 42 degrees, and we put that in our calculator, and we end up with 18.01 feet. So the height of the tree is 18.01 feet. All right, number 18. Says the horizontal distance from a plane to the airport is 30,000 feet. The pilot in the plane observes the airport at an angle of depression of 33 degrees. Find the altitude of the plane to the nearest 100 feet. All right, so your picture should look like this. Here's the airplane, and it says the horizontal distance from the plane to the airport is 30,000 feet. So that would be this horizontal segment right here at the bottom. That's 30,000. It also said the angle of depression is 33 degrees, and the angle of depression is always from the top, from the horizontal at the top. So that's 33 degrees here. Now we can transfer this angle of depression, 33 degrees, down to the angle that's inside the triangle, which is also the angle of elevation. So the angle of depression and the angle of elevation are always going to be the same. All right, we're trying to find the altitude of the plane, which is really the height of the plane. So we'll call that h, and we notice that h is the opposite side of this angle 33, whereas 30,000 is the adjacent side, so we can use the tangent. So we can say that the tangent of 33 degrees is opposite, which is h, divided by the adjacent side, which is the 30,000. We'll multiply 30,000 on both sides, and so h is going to equal 30,000 times the tangent of 33 degrees. And then we put that in the calculator. All right, and the height is calculated to be 19,482.228 feet. All right, here's number 19. It says a rhombus, shown below, is a parallelogram with 4 congruent sides and with diagonals that are perpendicular bisectors of each other. This rhombus has diagonals of 4 inches and 10 inches. Find the measures of the angles of the rhombus to the nearest degree. First, let's draw in the 2 diagonals. One diagonal is going to go from B across to the D, and then another diagonal will go from the A across to the C. All right, those are the 2 diagonals. Now it says the diagonals are 4 inches and 10 inches. So I'm color coding them. The blue diagonal from A to C, that's going to be the 4-inch diagonal. And the purple diagonal is going to be the 10-inch diagonal. Now it says that the diagonals are perpendicular bisectors of each other. That means that they split each other in half. So the blue diagonal that is 4 would become 2 on this side and 2 on this side. The purple diagonal that is 10 would be 5 here and 5 there. Also, because they are perpendicular to each other, then we know that we have a right angle in this corner. Now as we zoom in on this rhombus, I'll have this angle labeled as angle X, or X degrees. And the side that's 2 is the opposite, and the side that's 5 is the adjacent. So I can find angle X by using the inverse tangent. So I can say that X degrees is the inverse tangent of opposite over adjacent, which is 2 over 5. And let's plug that into the calculator. And so we have X is equal to 21.801 degrees. Also, it can be shown that this angle over here is also X. So angle D would be twice X, or twice 21.801. So we can simply just say the measure of angle D is 2 times X, or 2 times 21.801, which is 43.602, and they want us to round to the nearest whole degree, so that would round up to 44 degrees. Now let's look here at angle A. Well, half of angle A is, I'm going to call that Y. Now, the side across from Y is 5, and the side adjacent to Y is 2. All right, so we can say that Y is the inverse tangent of opposite over adjacent, so that's inverse tangent of 5 over 2, which comes out to be 68.199, which rounds to 68 degrees, which is to the nearest whole number. And then if you look at the measure of angle A, the measure of angle A is simply the measure of angle Y times 2. So A is 2 times Y, or 2 times 68, which is 136 degrees. Then the measure of angle C is the same as the measure of angle A, so the measure of angle C is also 136 degrees. All right, here's question 20. It says the steps to the front entrance of a building rise a total of 1 meter. The steps are to be torn out and replaced by a ramp for wheelchairs. The end of the ramp will be 20 meters from the entrance. What is the angle that the ramp makes with the ground? All right, first, let's draw a picture. All right, our picture is going to look like this. The height of the steps is 1 meter, and the distance from the building to the end of the ramp is 20 meters. And we're trying to find this angle of elevation, which is X. So we can say that X is going to be the inverse tangent of 1 over 20. Okay, and the reason why it's inverse tangent is that 1 is the opposite side and 20 is the adjacent side. All right, we'll simply put that in our calculator, and we get X is equal to 2.862 degrees. All right, and that wraps up the quiz review.